to talk to you about how mantle convection drives lithospheric plates. So, mantle is the layer of earth that's below the crust. Convection is a way to transfer heat, and we've talked about lithospheric plates being portions of the Earth's crust as well as the top part of the mantle in hunks moving all around on the asthenosphere. That happens because the asthenosphere is heated up by convection currents. So here we have a little visual of the Earth's crust, little mountains on top here. Then we go down and we have the mantle, which is about 2,000 miles thick. It's the largest, thickest layer of the Earth. Then we have the core on the center of the Earth. So again, the lithosphere is 60 miles thick and consists of tectonic plates. It's the top portion of the crust, it's the crust plus the top portion of the mantle. The asthenosphere is about 60 miles to 240 miles. It's a fluid layer, not liquid like water, but fluid like silly putty. If you leave a bunch of silly putty on a flat surface, it will soon just spread out. So that's how the asthenosphere behaves. Still a solid, but it spreads out. Convection equals the transfer of heat. It's one way heat is transferred. Heat is transferred in many ways. We're going to talk about how convection works in the mantle. A convection cell is an area of volume that has the same temperature and the same density. Here we have another graphic we have our tectonic plates. Some of them are colliding, some of them are spreading apart a little bit, and they're on the surface of the Earth. They consist of the crust and the top part of the mantle. So then we have the mantle here, and in the very middle of the Earth we have the core. So we have this convection going on where there's rock in the asthenosphere that gets heated up by the rest of the mantle and the core of the Earth. This rock gets heated, and because of the behavior of rock that's heated, it becomes less dense. It starts to spread out, molecules spread out, become less dense. So it's going to rise higher above the surrounding rock in this little convection cell. Hot rock is going to be less dense and rise up above towards the upper layers of the Earth. Well, the upper layers of the Earth are kind of coolish as compared to the center of the Earth. So once this rock makes it to the top of the Earth, it cools down. Well, cool stuff sinks. That's convection. Hot stuff rises, cool stuff sinks. So this cool rock starts to get heavier, more dense, and starts to sink down again. So here's an example of how that works in the mantle, how that works in the lithosphere. So I have a plate here, a lithospheric plate here, and a lithospheric plate here. We have upwelling of magma, hot rock, causing this to spread apart. Well, these plates are moving due to the convection in the mantle. We have our mantle down here, and we have rock on the bottom, closer to the core of the Earth, the lower part of the mantle, getting heated up. Well, hot stuff rises, so this convection starts to occur, the convection current occurs, this hot stuff rises up, gets close to the top, the crust of the Earth, where it is cooler. The cool rock gets higher in density, gets thicker, cooler, and cool stuff sinks. So we're back down now, this rock at the core of closer to the core of the Earth, where it's going to heat up again, heats up again, hot stuff rises, it's going to rise back up to closer to the crust of the Earth, where it's cooler, so it's going to get denser, thicker, and sink. So rise up from getting heated, cool down from sinking. Rise up from getting heated, cool down from sinking. And over here I just have another representation of that. Closer to the core of the Earth, it's going to get hot, rise up, it's going to cool off, close to the crust of the Earth, and it's going to settle back down again. Okay, for more information, you can always email me at rose_wignall@abss.k12.nc.us.